from here on, let's actually jump into a real application, and I will hand it over to Manoj to demo for us a real application which implements some of the messaging patterns that we looked at, and then we can look at some of the source code that was used to develop those applications.
Thanks, Manish. All right, guys. So let's look at the demo of how we have implemented broadcast and pub sub model in this application. So just to give you an overview of an application, this is a typical order management system and a stock ticker kind of application. So the idea here is that a user subscribe to a symbol, and only that user will get real-time prices for that subscribed symbol. So in this example here, I have 3 browsers open. Even though if I subscribe, so let's say in my Firefox client, if I subscribe for a symbol Yahoo, click on subscribe, the Yahoo gets added to my live stock table here, whereas my IE client and my Chrome client won't get that Yahoo subscription, because that's a typical pub sub scenario where a user asks for a subscription. The security gets added to that particular client. Now, if we click on open market, we see the real-time prices for these added symbols, and you see that only the Firefox client will get a price update for Yahoo, whereas IE client and the Chrome client won't get a subscription for Yahoo. Now, if we try to add, let's say, Yahoo again for my Chrome client here, so my Chrome client also gets a real-time price update for Yahoo. My Firefox client gets a update for Yahoo, whereas my IE client, since it has no subscription for Yahoo, it won't get those price updates. This is a typical use case for our pub sub model, where clients subscribe for a particular stock, and they will get the price update based upon the subscription. Another use case which we have and we talked about is the broadcast mechanism. So the order management system is primarily used for the broadcasting mechanism. Here there are various use cases, like you can create an order. So once you create an order, that order will get displayed to all the traders, right? Similarly, when you execute an order, the order execution will get displayed to all the traders simultaneously. When somebody edits an order, that addition or the updated values get pushed to all the clients. So let's look at the create order thing first. So in my Firefox client, if I add an order of Yahoo with side sell trader, let's say MKM, with a quantity of 1,000 and a price of $250, I do add. So you see that all the clients will get Yahoo as order added to them. If I execute, let's say edit, let's do the edit first. Let's edit the special instruction and quantity. So all the updates for the edit will flow to all the clients. If we try to execute this order, all the clients will simultaneously get the update for an executed order. So this is a typical use case for a broadcast, where all the connected clients will get the updates if one of the client will take any of the action on a order or or edit any of the orders. Now, from a code perspective, let's look at how we have implemented first the pub/sub model and then the broadcast mechanism. Now, in this, let's look at first the project structure. What are the various components of SignalR? When we start thinking about SignalR, how do we integrate SignalR on the server side or on the client side? Server side has two pieces, right? It has a server side component and it has a client side component. From a server side perspective, you need to add a reference to Microsoft.ASP.NET.SignalR.code. So basically what you have to do is to include a nugget package, which is a SignalR. So if you go to tools, options, and do the package library manager and add a SignalR from there, it automatically adds the SignalR.core, SignalR.owin, and SignalR.system.web on the server side. And on the client side, it will add a jQuery based client, which is jQuery.signalr.1.3.js and jQuery.signalr.1.3.min.js. This is the client side component for SignalR. So SignalR client side component is one JavaScript based library, and there is a .NET based client as well, which you can use in your WPF application or in a WinForm application. So that's the code. That's the structural part of a SignalR. Now let's look at how we have implemented a pub/sub model using a stock ticker example here. So on our server side, first of all, the important concept here is to define a hub, a stock ticker hub. So first, your hub class need to inherit from there's a class called SignalR.hub. If you look at just Microsoft.ASP.NET.SignalR.hub. So your class need to inherit from a hub class, and you have to provide the hub name. In this case, we have provided a hub name as ticker. Now there is so this hub is basically, as Manish mentioned, that this is primarily a RPC based mechanism. All you are doing here is defining some methods like get all stocks, get market state, open market, close market, subscribe. All these are basically methods on a server side that you call from the client side. So all these methods are basically a gateway that you call into. And then the real implementation is in class called stock ticker controller, which is basically an independent class that takes care of all the logic of basically subscribing the stock prices and basically publishing those stock prices. So let's look at an example here. So first look at the subscribe. So basically when we call subscribe from a client side, it calls a server side method called subscribe, and then we call ticker.subscribe method here. So what the ticker.subscribe method is a stock ticker controller .subscribe method. Here what we do is basically do a logic of adding it to the mapping collection and basically creating a stock, and then we define and add that particular symbol to the groups collection. So groups is another concept which hubs provide. Basically, so groups are, think about groups like entity or something like where you want to publish a data to a certain set of users. So basically you maintain a group by symbol and you add the number of connection IDs to that group. So if you have a symbol like Yahoo, and Yahoo has been subscribed by 2 or 3 clients, so you create a group by the name of Yahoo and add those 2 or 3 client IDs with the Yahoo symbol. And when you try to publish that, updated price, you publish a price update to a symbol. So all the clients who are basically registered to that particular symbol will get an update. In this case here, in our example of publish stock subscription, if you look at it, what we do here is that clients.group, which is stock.symbol, and then update stock price. So client.group will give us a group for that particular symbol, and then we call a method update stock price, which gets called on a client side. So if you look at group, client.group, it is basically returning a dynamic type of object here. The dynamic type of object says that this method will get evaluated at runtime, and the SignalR provides us a capability that this method will get called on the client side. So let's look at the client side implementation of subscribe method. So in our ticker.js, we have ticker.client.update stock price. So remember, on the server side, what we are doing is we are calling client.group.update stock price. So there is a definition of update stock price at the client side. So this method gets called whenever from a server side we try to publish the stock prices, and here we try to update the stock prices on the JavaScript view model. If we have to call the server side script method, the way we do it is right. So look at this. So when we have to call from a client side, when we click on a subscribe button, we call ticker.server.subscribe. So this method, this call here, will call a subscribe method on a server side controller, on a server side hub. The stock ticker hub subscribe method will get called when we call ticker.server.subscribe. So this is a typical use case. This is a typical code for client to server communication using SignalR, a pub sub model. Now let's talk about the order management system, which is a broadcast mechanism. So in this stock ticker, we looked at a way of implementing hubs which are pure RPC based mechanisms. Like hub is the one who is trying to communicate between client and server. Right? Now there is another pattern for implementing hub, and which is web API based, which we have used in our order management application. So think about order management. Think about the order management application is like any other web API based application, right? It's a RESTful based system where you basically send a data to a server, basically post when you try to create an order. When you edit an order, you do a server side put. When you publish an order or execute an order, you do a server side put. So it's a web API based mechanism. It's a RESTful way of calling the server. Now, in order to implement a push based mechanism, we have integrated a SignalR to it, so that all the clients will get updates whenever any clients try to take any action on an order or try to add new order. So that's where the SignalR comes into picture. Otherwise, it's a plain web API based controller. So let's look at the order controller first. So order controller, if you look at it, it basically inherits from API controller with hub, which is again a class which we have implemented. API controller with hub is basically a normal controller which inherits from API controller, like in any MVC4 application, right? So we have an API controller, we inherit our controller with API controller. What's the role of this controller here? If this controller manages the hub instantiation and maintains the instance of hub. Since we need this controller to notify all the clients as well whenever there is an action on a order, so it needs to maintain an instance of hub. That's what this controller is doing. If you look at the order hub, it's pretty simple. There's nothing, no line of code here. It's just a hub name. It exposes, it inherits from a hub class, and it just exposes the hub with a hub name, which is in this case is the order. So unlike the stock ticker hub, which has lots of methods like closed market, open market, and all those kind of things, which is a RPC-based mechanism, this class is pretty simple. This is just a hub declaration, and your API controller will maintain the instance of this hub. Now, our order controller, while creating an API controller with hub, it says that what kind of hub it needs to maintain. In this case, it says that it's an order hub it needs to maintain. Right? So, on a server side, the code is pretty simple. When we try to add an order, we say, so it's like you guys already know that it's a web API based syntax. So verb, HTML verbs is what is being used. So any request that goes to the server automatically matches the HTML, HTTP verbs. So in this case, post add order will automatically, the post request will call this method called add order here, which tries to add an order to the system. And then after adding an order, it does call hub.client.all add order. Hub.client.all, what it does is saying that broadcast this order to all the clients. So see the difference here. So in a broadcast mechanism, you are saying hub.client.all, whereas in case of pub sub mechanism, you are saying client.group.stock_symbol.update stock prices, right? So basically there is a mechanism at every level where you can specify whether you want to publish or notify a set of clients or to all the clients, or do I specify clients? So in this case we have said in the broadcast mechanism, we have said that hub.client.all add order. All is again is a dynamic object. It does a dynamic object, and add order again gets called on the client side. Right. Similarly, when we have a edit use case, which is an update order, it says a put request. So server side, since we have multiple put requests here, put update order, put allocate order, put place order, so we have to specify the action name like we do in web APIs anyways. You have to specify the action name for if we have more than one verb defined for a HTTP request, then we have to specify the action name. So in this case, we have said that the action name is update, and when after updating the order in the system, we again broadcast this update to all the clients. Similarly for allocation as well. We subscribe, or basically after marking the order as an allocated, we push the status to all the clients. Now let's look at from the client side, how does this get called? So we have an order.js basically, which talks about, before we jump into looking at how we call these various methods from a client side, one important thing which we should look at now is how we establish first a connection to the client, to the server, to SignalR server, and basically how does this entire connection mechanism work. So if you look at order.js, there's a dollar function, which obviously is a jQuery method of saying once all the scripts are loaded, then execute this function. Here we create an instance of first the view model, and then we specify $connection.order for order hub and $connection.ticker for our stock ticker hub. Then we specify, then after specifying the order, basically these are the client-side functions that get called from a server. Let's ignore them for now. What is important to know for now is $.connection.hub.start. This will start the connection with both the hubs. So basically $connection.hub.start will actually initiate the connection with your server, with your hubs. And here in this case, so basically this is a jQuery based mechanism, so we basically specify once this starts the asynchronous call, we say once it's done, then get all the from server, get all the stocks, and then once all that get stock is done, then add them to the stock ticker view model. Now let's look at how we are calling the server code from a order.js. Now when we try to add an order, we call send create method, which is basically here we are specifying, it's a normal jQuery based call. Here we are specifying $.AJAX, giving the URL, which is like normal API/order is our controller, data to be sent, and then the type of the request is a post request. So we are sending this request to a client, to the server, and once the server gets this request, it adds the data. It post add request, right? So basically, in this case, we are not specifying add request anywhere because there is only one post, and it automatically matches with it. The system is smart enough, the web API is smart enough to match the HTTP verb post with the post keyword here, and it automatically calls the add order. And once it adds the order to the database, your order database, and then it calls the hub.client.all.add order. Add order is again a client-side function. Look at it here. Order hub.client.add order. This is a client-side function that gets called, and again here we add the order to the JavaScript view model. So it gets added here. Similarly, there is an update order on the client side, and then there is a similarly there is a client side method for the allocation and execution. So that's pretty much all we have from the demo perspective. Now let's look at some of the nitty-gritties of under the covers. How does this all work, right? So remember Manish talks about the negotiation bit. How does SignalR supports 4 different types of protocols, which is long polling, server-side events, forever frames, and WebSocket. How does this all work, right? And how does client and server know that which transport to fall back to? So let's look at some of those details. If I start a fiddler, all right. So let's look at now, if I refresh my IE client, look at this. So the first bit is called SignalR.negotiate. This is where it says it creates a connection. Basically, it sends a connection token and the connection ID. It gets that in response basically, and it says whether it needs to try a WebSocket. In this case, it says false basically because in Win 7 there is no support for WebSockets, obviously. Then it fallbacks to long polling because you see all the request response that happen after that is using long polling. So you can see in the URL, basically SignalR./connect, when it's tried to connect, it says the transport is equal to long polling, and the connection, it sends the connection token whenever you have the connection token is the same connection token which you get from the negotiate call. So basically every web browser or client you connect to a server will call this negotiate, SignalR.negotiate. It gets the client ID and a connection token which it uses to do further communication with the server. If you look at that SignalR.send, in this basically send same which we use to get all the default stocks. Here it says that it is using the transport protocol as long polling, and then uses the same connection token. Yeah. Now let's look at the Firefox. If I do a refresh on Firefox, again the Firefox calls a negotiate method. Here also it gets in the response it gets a connection token and a connection ID. It says the try WebSocket is equal to false because obviously there is no WebSocket support. Now, but the transport protocol here is a server-sent event. As Manish mentioned, that Firefox supports the server-sent event, so the SignalR is smart enough to fall back to the server-sent event. So from a programmer or a developer perspective, now we don't have to actually care about here whether I am coding against the server-sent event or my server or a client supports server-sent event, or whether it supports a long polling or whether it supports a WebSocket. All I need to care about is code against my SignalR library. Similarly, if I do a refresh on my Chrome client, my Chrome client also uses a server-sent event in this case. Yeah. So the important thing here to note, there is a sequence in which this fallback mechanism works. First, it tries to upgrade itself. It tries to use a WebSocket. If it did not find a WebSocket mechanism, in this case we saw that it says the try WebSocket is false, then it fallbacks to server-sent events. And if a browser does not support server-sent events, as IE does not support server-sent event, it tries to fall back to forever frames. So our IE client tried to connect using forever frames, but then it seems like there is some issue because I'm running with i9 compatibility mode. There is some issue with forever frames, so it uses the long polling mechanism. That's the last fallback option. That's pretty much it from a demo perspective.
So, to conclude, we looked at some of the messaging patterns that a typical push application, a typical application which deals with real-time data which needs to be pushed to the client would need. We saw how they were implemented traditionally. We saw how how HTML5 recommends we do them, and then we saw why it is more beneficial to actually use SignalR instead of using any one of those different mechanisms. because SignalR basically negotiates based on the currently connected client and the current state of the server. It negotiates the appropriate mechanism and makes it transparent for us, and we can focus on the business logic and have our application support push technology. So with that, we will conclude the session and open it up for questions and comments from the audience. So feel free to type in your questions, and as we get them, we'll try to respond to them.